My name is Nicholas Allen. I've been accused of being a program manager here at Microsoft, where I work on technologies such as Windows Communication Foundation, Windows Workflow Foundation, and the newly announced Windows Server AppFabric. And really, though, I'm a developer. I love writing code. And I hope most of the people in the audience here today are also people that love writing code, because when we talk about extensibility, we're going to be down inside the guts of the platform, where we're actually going to change how the platform works, enhance the programs that you're writing, and get a little bit down and dirty. And I don't want to scare people off. For people that are not expert developers, there's many extensibility points that I can customize how my program works in 5 lines of code if I want to change how a particular variable in my persistence system is going to be written out, all the way up to planning how I do a 5,000 or 10,000 line project to completely replace how persistence happens. Let's say I don't like SQL Server, I like Oracle. I can do that on top of the AppFabric platform without having to modify how my applications work. I want to thank all of you for coming out here today. This is the penultimate series of sessions on the final day of PDC, which means that you are very, very committed to still be alive and well, having attended so much quality material. Within 2 hours, you will officially be survivors of the PDC 2009 experience. When we went to put together the series of sessions for the AppFabric, I drew this little picture just for myself in order to figure out how all the sessions relate together. And it turned out to be useful enough that I want to communicate it to you, not only for how our sessions relate together, but also kind of a zoomed-in look at the architecture of the AppFabric system. So I think of the world as being divided basically into 4 layers when I talk about the AppFabric. At the bottom layer, I've got the process host. This is what's giving me my threads, my runtime environment. The common process hosts that you're going to be using are things like IaaS. If you're not using HTTP, you might be using WAS instead, the Windows Process Activation Service. It's a component within IaaS. You might be in the cloud, but you're in some way being given form and execution to your program. On top of that process host layer is the runtime layer. And the runtimes are a series of different technologies that we put out. We've got WCF for a runtime for sending and receiving messages. We've got dubf, it's a runtime for processing activity-based programs. And a little bit new for 4.0, we're kind of breaking out as a runtime piece some of the services for persistence and monitoring that were previously tied in together with workflow. And persistence is a way that I can take instancing, and instancing comes as a concept in both WCF and the dubf worlds. And I can make those instances persist in some durable way to a storage location, bring them back up at a later point in time. Also there, we've got monitoring, which is a way that I can look at my instances and see what their ongoing execution is like and record the events as they happen. On top of this runtime layer, we've built the application hosts. You might have some familiarity with our application host. For WCF, it's the service host. For dubf, I was typically building my own application host. And this is the piece that controls my application execution. It is the high-level container in which I actually put my code. And on top of those, we've got the actual user experiences. So in the upper left corner there, we've got the developer user experience for building a workflow application. I'm going to build an activity-based program. I might use the Visual Studio Designer experience in which to do it. In the upper right, we've got the kind of the IT Pro user experience where I'm administering an already written service. It's deployed out to the world. I want to control how those services are working. And if you've seen the previous talks about AppFabric, you've seen that a lot of that is built into the IaaS management console. I've got all kinds of new features in terms of looking at my dubf and WCF services and able to control them both through the graphical experience of the IaaS console as well as through PowerShell. I'll be focusing on that middle set of components there, which I've highlighted out in orange. And this is going to look at the extensibility for how I change that application host, perhaps even write my own application host, as well as change or write my own solutions for persistence and monitoring. This talk is not really going to sell you on workflow. I'm assuming that you know the workflow system decently well. You don't necessarily have to have written a workflow program in order to appreciate the talk. Because this is extensibility and you're in the guts of the system, you actually don't see a lot of workflow down at this level. You're writing code just like you would for a code service, but you're doing it as a way to support the ongoing execution of workflow programs. So I've picked out a couple of those value propositions that you probably have heard. So you've heard people talk about how workflow allows you to build protocols that have coordinated work done in an easy fashion, even if I've got all these asynchronous calls coming in and out. Workflow mediates that for me so that I don't have to worry about this asynchronous programming model. You've also probably heard from the developer experience if you went to the activities talk yesterday, then you saw things like customizable vocabularies, building my own designers, doing the declarative programming experience of workflow. But I'll be focusing in on the state visibility, the state persistence, and extensibility aspects of the workflow model. Because of the fact that I have a declarative program that is modeling how my application is going to execute, I can actually start rationalizing about the internal state of my system. I can look at the state, see the variables of the system, see the arguments of the system, and use that in order to build services on top of that. And when I say services in that context, I mean the infrastructure services that are provided to you. One example of an infrastructure service is state persistence. Once I know what your application state is, I know what variables you have, then I can take as my responsibility recording those variables to some location, removing your process from memory, and then bringing those variables back at a later point in time. And you, as the application developer, don't have to know about that at all. It's entirely a service that can be provided by the system. So let's really quickly jump into how workflow execution works, because the value of those infrastructure services comes from having a constrained execution environment. You think about how C# and CLR kind of changed the world. It was because you were constrained to write programs in a certain way. When I was writing a managed application, we kind of had taken away from you the ability to directly manipulate memory addresses and where my objects were in memory. And in return, by constraining what programs you could write, you could get the services like garbage collection. Workflow has a similar type of trade-off there, where I constrain my programs to have pulses of work. So I think about the workflow runtime as something like an operating system thread scheduler. It has knowledge of the set of work items in my system. Those are the activities, the program definition that's going to tell the runtime, the exact steps that I want to execute for my program. We're going to have the application state. That's my variables, my arguments, the things that are in memory representing the ongoing evolution of my application. And we're going to have some number of machine resources. Typically, we care about things like threads and memory. And periodically, the workflow runtime is going to select one of those activities to go off and execute. And it'll give it a pulse of work. In between the pulses of work, I don't know what's going on in the system. I only write to the description of what happens when a pulse occurs. And so in between pulses of work, anything can go on as part of one of these infrastructure services. And persistence is a key example there, where in between a pulse of work, I'm going to take all of your application state, put it off into some third location so that it can be out of memory. I can take your process down, bring it back up at a later point in time, and you don't notice because you never see what happens in between those pulses of work. The workflow runtime, though, is a pretty closed system in terms of interacting with the rest of the world. All it has is a way of communicating through events what is happening inside the runtime, as well as communicating through events to control how the runtime is going to operate. And it's the responsibility of the application host to actually control that workflow runtime. So the application host is what's going to wrap around the runtime and exchange events back and forth. For example, the application host may say, load this instance. Now go and run this instance for a while, give it as many pulses of execution as you like, and then later on the application host will say, that's enough time. I want you to now save the instance, so you give me back all the state inside, and I will actually, as the application host, take responsibility for bringing back the state of the instance that I got from the workflow runtime and using that to record progress. The application host is also the one that does all the communication with the outside world. So when you have something like messaging, so workflow services, where we combine WCF and WF together, it's actually the application host that is doing all the communication, translating those messages down into the internal events that we have for the workflow runtime. So if I want to control how the workflow gets inputs or stimulus from the outside world, I can do that by either changing the application host, building my own, or using one of our application hosts that already provide those capabilities. So the first extensibility point that I want to talk about is actually choosing among the different ways of writing an application host. So I've got a variety of different ways that I could go about this. If you've been using workflow in the past for 3.0 and 3.5, you're probably pretty familiar with the idea of writing your own host. I'm going to take a bunch of different workflow instances. I'm going to wire them together however I want. And we provide, in 4.0, the workflow instance class is the representation of one of those little instance boxes. And I can hook those instances together. I can control exactly how the instances are executed. I can control everything going in and going out of those instances. It's entirely my responsibility for wiring the system up together. And this type of host, which is just building a custom host, I can do it pretty much anything I want. But often I have a pretty constrained scenario in terms of the types of applications that I want to build. And I don't want to go through this process of writing a custom host, which is a lot of work, every time I want to go off and build an application. So I want simpler experiences for hosting my workflow programs without having to go and worry about this low-level detail of instances. So the first one I'll talk about is when I've got a scenario I'm terming workflow-driven applications. So imagine I've got something like a UI program, and I want to drive the behavior of that UI through a workflow. You might have seen some of the previous demos for things like Visual Studio, where I can describe the build tasks through workflows. You might have seen Dynamic CRM, where I can describe my business process through workflows. All I'm doing is driving behind the logic by writing that workflow program. And I can do that using a workflow application. Workflow application is an out-of-the-box host we give you. It has a single instance inside, and it has a relatively high-level set of primitives that I can use in order to control how that instance is going to execute. So workflow application will let me load, save, run, persist instances, unload them, and so on. So I don't have to worry about that low-level eventing model. I can just have an out-of-the-box application host that works for my workflow programs. A second host that we provide out of the box for you is for workflow services. So if I want to have messages as my way of communicating with the outside world, I can do that through WCF. I can pick any of the bindings, any of the protocols that WCF supports, and use that as a way to control the instances and control the data going in and out of my programs. As a side benefit of doing messaging as my way of thinking about the world, if you've used WCF, you know that WCF has an instancing model. I have the ability to control how many of these messages I'm going to process at once. If I have multiple messages for multiple users, I can actually spin up different copies of my service and process those simultaneously. So Workflow Service Host similarly gives you the ability to process multiple instances of my workflow at the same time, and it takes care of all the details of actually wiring up those multiple instances together, making sure that we have a consistent view of the system, making sure that there isn't two messages going for the same instance and so on. It takes care of all the details under the covers for you. And if you've used WCF, probably the first thing people will actually run into when they have instances in WCF is the default out-of-the-box setting is about 10, which will fall over in about 5 seconds. And you always have to bump up the number of instances that I'm going to have available for my WCF services. I can increase the number of instances that are running on a particular machine, but eventually I'm going to run out of capacity. A WCF service host is running in a single process, a single application domain, and there's only so many instances that I can fit into that world before my machine can take it no longer. And what I have to do in that case is then to start scaling out my service. When you're using AppFabric, you're going to get a lot of tooling around being able to do that scale out. So imagine that my service has grown just too large. My business is too popular for me to run it on a single machine. I want to take that same model for service hosts, for workflow services, running multiple instances of my service, and bring it out to a cluster of multiple machines. So I've given myself 4 machines here to play with for my scale-out service. I can go and provision those machines, installing the same service host to each of them, and they will all start processing messages for the workflow definition that I've given, sharing the instances among them using a common instance store. And I can do that, both the setup as well as the creation of instance stores, the management of persistence as part of my application definition through the tooling experience of AppFabric, so I don't have to actually do any of that by hand. So let's look inside that system. I've taken one of the machines out of my cluster, zoomed in on it, and let's actually talk about how we manage distributed state. Because as soon as I tell you that I've got not one machine, but many machines that are all talking about the same state, we start running into coordination problems. We have to worry about who has the consistent view of the system. We have to worry about who is going to be currently changing the state of the system and making sure that we don't have any conflicts. So in this picture, I've got a zoom in on one of my machines. You can see the application host running on the machine, as well as the activation that's going to bring those application hosts into being as necessary. All of the machines in my cluster are going to be talking to a centralized instance store. That instance store is actually just a data tier. It could be itself implemented by multiple machines. But we'll think about it as a single concept for right now. And that instance store, which has my instances in it, is the single source of truth in my system. Everyone else is potentially telling lies. Because when I've got a distributed system, as soon as I have networking involved, we can get machines that are out of sync. So I imagine that on the first machine here, I've loaded instance number 3, and it goes off and happily processes it for a while. But now I think that this machine has crashed. So I'm going to bring it down. I'm going to let someone else use instance 3. But in reality, it was just a network disconnect, and so it's still running. I need to be able to mediate the fact that I don't know the true state of the system on all the machines. In past releases, we actually did it a little bit differently. We said we're going to centrally coordinate. We're all going to agree on the state of the world, and so everyone is going to have a consistent view of everything that's going on. That's great for a small number of machines, but as my scale grows larger and larger, that central coordination starts becoming a bottleneck because everyone serializes on doing that coordination, making sure that they agree about the state of the world. And so when I build out a system like that, I've got one machine. Need more capacity, so I put a second machine in. Great, I get most of the capacity of the second machine. I barely notice the hit. Now my business is continuing to grow. I put 2 more machines in. I'm starting to see a little bit of a downgrade in terms of how much capacity I'm squeezing out of each additional machine. So I put 4 more machines in. And as I go further and further up in terms of scale, I start seeing less and less return because all the machines are talking back to a central source. And so we went with a second philosophy for how I think about the world and coordinating instances. And that is, we're going to be very tolerant of errors. As soon as I say errors are OK, what I'll do is instead of falling over the first time an error occurs, is to recognize when an error occurs and figure out how to fix it. So when a message comes in, it goes to the wrong machine because I've got the instance running somewhere else. That's OK. We'll make sure that the message and the instance eventually gets together so that I can continue execution. And in this way, we don't have to have consistency within my data center before I do any routing decisions, any instancing decisions, doing any state updates. We can let all the machines go off in parallel. We'll fix all the mistakes that happen if we mess something up. And so we'll correct it and come to an eventually consistent system where I'm continuously moving forward the state of my application. So these machines are talking to this instance store through a series of APIs that I'll be showing you today. And there's 3 different inputs and outputs that are going throughout the system. I've got application events. If I'm using workflow service hosts, so I'm using WCF messaging, these application events are the messages that are coming in and out. And the messages could be going directly to my service hosts if they're already running, or they'll go to my activation system if I need to bring the host into being before I can actually process that message. Once the application host is running, it's loaded an instance, it's doing work on it, then it'll be doing updates back to the instance store saying, here's how these variables have changed since the last time I took this instance out. The third component is what actually happens when I want to have the instance store tell me that there's interesting work to be done. And there's a couple scenarios where that could happen. Common scenario you've got is I want to have my workflow pause for a while. I want it to wait for a week before it does the next piece of work. And so I'll put a delay activity into my workflow saying, come back in a week and bring me back into memory. So we need some way for the instance store to tell us that, hey, a week has passed. This workflow is ready to run. Even though you haven't received any messages, go and load it back in. Similarly, when I have a machine in my cluster crash, it potentially has a bunch of instances running on it. And I want to restart those instances on some other node in my system. Only the instance store knows about the fact that that machine has crashed. Only the instance store knows about those instances that need to be run. And so there needs to be some communication back from that instance store able to provide inputs into the application host saying that there are instances that are ready to go. In the beta 2 bits that you have, and now I'm going to do a little bit of a future preview where you have bits in your hands, go off and build on them, and then there's the bits that are actually going to ship in .NET 4. So I will give you both what you see today in beta 2 as well as what you'll see in the final release so that you know what's coming, you know how you can change your programs in the future, and you'll know kind of a little bit of a sneak preview so that you see exactly what we're doing as part of our plans for the final release. So in beta 2, if you saw this for Mark Fussel's talk earlier today, there's a workflow management service, which is responsible for communicating together with the application host using messaging, saying, there's an instance ready to run. I'm going to scan my database from my workflow management service and send messages out to all the application hosts that need to do something about it. Turns out that sending messages is not something that you want to do if you're not already using messaging. So remember the simple host that I had, like like workflow application, or if I want to build a custom host that's not using WCF, I don't want to have to build a WCF endpoint just to have my instances come back into memory when I have a delay or a machine go down. And so what you'll see is actually an additional set of APIs for an event notification system. That event notification system will tell me for a running application host when there's work to be done on new instances. And I'll show that to you later in the talk. There's still going to be a service that comes with AppFabric, which I can run on machines, and that'll actually do the same event notifications, and it'll interact with the activation system so that when an event notification comes in from the instance store, we can actually spin up one of the service hosts just as if it was receiving messages, but without having to actually have application traffic going back and forth. Finally, once I've got my data in the instance store, I've schematized out my instances, I can build tooling on top of that. So I can go query the instance store, find the state of my instances, look at them, and visualize them in a way that works for the rest of my application system. So let me do my first demo, which is the quick view of looking at how you can customize the persistence system. And this is a really common scenario that we see a lot. You saw this potentially in Matt Winkler's talk when he went and did a demo for his file search routine, which was looking at all the files in his system. And if you notice, when Matt was doing his demo, he went and looked at the SQL in the instance store, and he actually had a column that was promoted out, which was telling him exactly how many files he had found. And if you tried to write that same service, you would notice that you didn't get that column. So here's how Matt actually did that under the covers. We've got a class called the persistence participant, and I use this class as a way to customize how data is going to be represented during a persistence episode. So imagine that my workflow has been running for a while. It's got application state that's ready to go. I've decided to persist it. And now I want to override exactly how it's going to be stored in the system. What Matt did was he found out where the storage location, and these are all just X named based on my variables, my arguments, all the data that I have. So he found out what the storage location was. And then he picked a new storage location that he was going to promote that data out to. So he had a complex type, which was representing his variables, because it's most convenient to work with your variables however your code is already structured. But he wanted to promote a simple type out, which was just a single string or integer, saying here's exactly the thing that I want to query on, because it's much easier to write a select statement on a string than it is to grovel through a big binary blob. So he picked out a new storage location, and then all he did was write this callback for the persistence participant. So the persistence participant that I plugged into my application host is going to get passed in all the variables of my system, and I'll tell you why there's actually two of these dictionaries rather than one of these dictionaries in a second here. The persistence participant got passed in all the variables in my system. It looked for the variable, which was my account. If it didn't find any, it said, OK, I don't have any data to give you. But if it did find some, what it did was just build out a single entry in my dictionary, which says, I'm going to promote out the account name. So I pulled out one piece of my complex type, which is now just a simple string. I put that back into persistence, and now it's going to be persisted side by side with the instance data. So I can go and query this without having to go and penetrate the structure of the instance blob. And the reason why there's actually two of these is because there's a distinction between data that is going to come back when persistence is loading my instance versus data that I just want to give out to the instance store, and I'll only use it in tools. I don't want it back later when my workflow resumes. So you can actually specify that this is data that I don't want to round trip. I'm going to go and query it, and you can save size of the data going back and forth whenever persistence happens by doing that. On top of that, Matt did a second thing. And here I'm showing you what the instantiation of one of the instance stores. We can have out of the box an instance store that uses SQL Server. So it's the SQL Workflow instance store. And he didn't just want to be able to write a select statement. He also wanted to have indexing on that column. So he needed to promote the data not only out of the instance, but also into its own column so that he could put an index there. And so what he did was to put a promotion on the instance store. The promotion tells me to pick one of the variables out of my system, and I could have put any number of variables in here. And it'll actually take the data out, having seen it come through persistence, and make its own column so that I can go and query on it very quickly. And this promotion system works for specifically the SQL Overflow instance store. You could build a similar type of system if you had a custom instance store, but we'll look at that later in the talk. So let me go on and tell you the second bit about why we actually did all this work for writing a new persistent system. And that was to support a really common request that we had for workflow. It's a feature that is already supported by BizTalk Server, and you've probably heard it described in talks already, which is a feature called correlation. And it turns out that in the real world, when I'm integrating two enterprise systems together, it's very rare that we agree on the names of things. So if I'm running my online store business, I might have particular names for all my customers. I'll say that I'll create accounts for you. I'll identify the account by your email address. And I'll recognize every time that I have a transaction with you, whether it's to receive your purchase, to query about the things that you've bought, to ship a package out. I'll correlate on the name of your account in order to find the data in my database. But even though I could build out my nice online store, I'm never going to be an international shipping company. And so I have to work with someone else, a partner, in order to actually get you the packages. And that partner is never going to agree to use my usernames. I can't convince them, as they're a tremendously larger company than me. They're always going to use their own internal identifiers. So now I'll sometimes have requests for the same piece of state referred to by different names. So when my customer talks to me through my web app, they'll tell me what their user account is. And when the shipper tells me that this package has been delivered, they'll tell me the delivery ID of that package. So I have to have both of those as ways of finding my state, because I want to have the user eventually query, ask me when is my package going to get there, and I'll tell them what I heard from the shipper earlier. We do that through the feature called correlation, where I can pull data out of messages, and it can be potentially different data for every message that I receive. And I'll use that information in order to find one particular instance of my system. Under the covers, the way it works is you take these correlation queries, and I've given you an example of a correlation query written as an XPath. I'm just going to grovel through the message, find either the username or the tracking ID. We'll pull together all this correlation information. We're going to throw in a couple more pieces of information related to the type of the service that you have, so that we can distinguish multiple services running through this on the same database. We're going to hash that all together into a 128-bit number. And then we're going to go off to the instance store and figure out which instance we're talking about based on that correlation key that was computed. And this is really common from the database world. Whenever you have two people that disagree on what the primary key should be, what you do is turn both of their primary keys into foreign keys and make your own primary key. So you solve the disagreements by saying, we're going to agree to disagree. And instead of having two bad choices, we'll have a third bad choice, which is equally hard to figure out which piece of state I'm talking about. As soon as I introduce multiple names for things, my world changes very dramatically. If you think about when you're using a language like C, I have pointers. When I've got pointers, I can put two pointers at the same piece of memory, aliasing them together so that one pointer, even though they look like two different addresses, are actually overriding the same piece of state. In previous versions of workflow, when we're using context exchange on the instance identifier, I always knew exactly the name of the instance I was talking about. I always knew that I was talking about this particular piece of state when I saw a message. Once we introduced correlation, that guarantee was broken. I could actually receive two messages, find two completely different correlation keys. But in reality, those two messages were going to try to modify the same piece of state in my system. And so that necessitated the creation of a new system for persistence that could actually deal with having multiple concurrent modifiers, having multiple names for the same piece of state, and do so in a consistent fashion without killing your performance. So let's quickly go over the organizational structure that lets us do that. So if you remember that big instance store container I had? Inside, there's actually 3 different pillars of data. If you've seen some of the cloud app descriptions, this is actually a very similar way that they do partitioning of their data as well. So I've got one pillar, which is my instance keys. Those are all those correlation keys that I computed, each of which refers to a particular instance. Also attached to the instance keys is any amount of metadata. This is something that you control as if you're writing your own application host. You can put whatever metadata that you want in there for your purposes. common use of metadata for instance keys is something like, I want to record as debug information exactly the pieces of the message that was used to create this instance key. So I'll stash that in the metadata. It never comes back when I'm actually querying my instances. But if something goes wrong, I can debug into the system, look at why this key was created, why my messages were not going to the right place, by using the metadata as a debug aid. The second pillar, which is what the instance keys are pointing to, are my instances. My instances are where I'm actually storing the information about my application. So that's the big box, which is the instance data that has all of my variables, all of the application state I need to resume the system later. Instances, similar to instance keys, have metadata. So here's where I store things like whether the instance is suspended, not allowed to run anymore, the errors that have occurred. So I can visualize through something like AppFabric what is going on in my system. I can turn particular instances off if I don't want to process them. And then finally, the instances have the concept of an owner. And the owner is who is currently got exclusive access to be able to modify this instance. So when one of those application hosts walked up and said, I want instance number 3, we're going to first look in the instance store whether instance number 3 is available. If it's not, we can tell you actually where instance number 3 is currently loaded. But if it is available, I'll give it to you. I can't let anyone else also have the instance. But at the same time, it's possible that after I give you instance number 3, your machine crashes, you never get back to me releasing the instance, and so I don't want to have to go and have some way of collecting all these stale locks. So even though the locks are exclusive, we can actually steal them from process to process in our distributed system. And we'll recognize when a lock has been stolen and used in an inconsistent fashion through a monotonically increasing set of values, which is giving me the version of the instance. So we can actually reconcile when we have network partitions, network crashes, recognize that an instance has been given out more than once, and prevent you from corrupting your data or incorrectly persisting the current application state. So we actually take care of that as a service for you. Finally, we've got the concept of these lock owners, which is our third pillar. And that's the identifiers for the people that own those locks in the system currently. Typically, a lock owner is going to correspond one-to-one with an application host. So if I have a workflow application, it acts as a lock owner. It has, within a lock owner, an assumption that that all the instances that you have locked, you know about, and you have coordination within your process so that we don't have to do any of this high-level coordination work in order to make sure that the operations you're doing are safe. When you've got something like Workflow Service Host, again, it'll be a single lock owner, but it'll have multiple instances. And so Workflow Service Host is actually taking care of the coordination between the instances inside of itself. So regardless of which particular thread of execution within Workflow Service Host receives the message, it can access the same state that the entire service host as a whole has locked. And so now let's look at the code side of this. What would I have to do in order, as an application host, to use one of these instance stores? And the really big one, which is, I want to replace an instance store. I want to completely change how my data is stored. How do I go about doing that? So we'll look at a couple of different pieces here. And the abstraction that is sitting between the application host and what I've been describing as the instance store is cleverly called instance store. So you'll recognize the C# types. But in between, we've actually provided a number of services for you. Because once we have the ability to understand how your data is organized, we understand how the data is going to be used as the instance store, we can do things like take care of transactions for you, take care of locks, take care of consistency issues. And so you'll see this layer in between called durable instancing. That's the piece I kind of pulled out as the runtime for persistence, which is going to give me all these services under the covers. Over time, we're looking at potential ways that we can make it easier for you to write application hosts, easier for you to write instance stores. So tell us if there's something that we do currently in our hosts that you would like to have done for free. Example there is Workflow Service Host able to manage multiple instances, able to resolve conflicts between the instances whenever I have multiple messages coming in. If that's something that you'd like to have as part of the built-in durable instancing, let us know. So I'll start by looking at it from the application host side. I'm writing an application host. And the nice thing about the way this is set up is that I've actually decoupled my versioning between the application host and the instance store. So I can write an application host like Workflow Service Host, and anybody can come in, plug in their instance store, whether it's written using SQL Server, written using Velocity, written using Oracle, written up to the cloud. I don't have to change my application in order to use that new instance store. Similarly, if someone writes an instance store, so I'm an ISV, I go to all the work in order to build my own storage solution, no matter which hosting choice I picked, whether they're using Workflow Application, Workflow Service Host, writing their own custom host, I have that entire base of customers that are able to use my instance store because the application host can be plugged in and out just as the instance store can be plugged in and out. So from the application host side, I'm going to walk up and create a new instance of one of these instance stores. So this is just my in-memory driver that's going to be used to talk to that instance store. And I picked the SQL Workflow instance store here again. And I'm going to create a handle. And a handle is just the corresponding equivalent of a DB connection. Under the covers, you can decide how these actually map down to physical resources. So there's no requirement that you have an ongoing network resource tied up for each of these handles. Over the lifetime of an application host, I'm probably going to create many of these as I talk about different instances at the same time. And then I'll use the handle in order to run commands. Commands are basically an iDispatch mechanism, where I tell you, here's the name of the operation I want to do. Your instance store can decide exactly how that's going to be translated into its native representation. So when I give a command to the SQL Workflow instance store, it's going to recognize that I'm running the create workflow owner command. It's going to translate that into some stored procedures to call. If I was writing an in-memory store, I would just take the command, recognize that I was creating an owner, and do whatever operations I was doing in memory. There's no forced coupling between how we talk about the system from the host side and how you have to actually build it out. So I'll go off and run my command. And now that I've done that, I've gone up to the instance store and say, hello, I'm a new instance owner. In the future, I may be taking control of some of these instances. It's just introducing myself so that it knows who I am. Here's where, going forward, you would set up the event notifications so that you get callbacks telling you when there are instances that were appropriate for you to run. We'll look at that in a second. If I'm in beta 2, then what I would do is instead of getting callback notifications, I would have a web service endpoint sitting off of my application host, which is the control endpoint. And that would be the one that's actually waiting for messages telling me what I need to do for the system. So going on, the next thing I want to do after I've created one of these lock owners is to be able to load a workflow. And I'm going to do it through a correlation. So I'm going to load the workflow using one of the instance keys that I've calculated. I'm going to give it the instance key I calculated. I'll tell it whether or not I'm expecting an instance to already be there. So I can say whether this is definitely an activating message versus a non-activating message. In this case, this is OK to activate. So I'll say that if the instance doesn't already exist, go ahead and create a new one when I make this request. And then I'll go execute that command and get back at one of these instance view classes. Let me jump to the definition here so you can see what that looks like. The instance view is my transactionally consistent view of the world. So it's my easy to access. It's just a bunch of property bags. This is all the state of my application schematized out from the instance store. And I only see the atomic, consistent updates of the system through this instance view. So I don't have to worry about ongoing transactions. I don't have to worry about locking. If I get values back, I can assume they're correct. And if that ever changes, because someone out from under me has changed the instance, when I go back to persist, the persistent system will recognize that the instance view that was previously given to me was actually incorrect, and it'll block me from persisting so that I don't make an incorrect state update. I then go off and use that instance data that I pulled back. So I'll do my computation. I might start up a workflow runtime, give it the instance. I'll hydrate it back out using the collection of data that I got. I'll make whatever updates I want to do. And now it's time to save. So I'll run another command. So I'll come back to the same instance store, the same instance handle, and say, that instance that I loaded previously, I want to save it. And in this case, I'm not going to use the instance anymore. So I'll say, go ahead and unlock it as well. I don't want to use it anymore. This will be what I'll do typically when I'm about to unload the instance. Alternatively, I could take persistent snapshots at any point in time and say, I'm going to continue using the instance. There's no requirement that I couple together persistence of the instance together with unloading the instance. So it'll continue to be mine after I do the save. So I'll go off and do this and execute the save command. And then finally, I'll do some cleanup. I'll just tear down the workflow owner so that I no longer am registered as a lock owner from the system, and I'll free up the handle. I would only do that for an application host as I was about to shut down. This is the application host side. And so you see it's maybe 20 lines of code that I'm writing in for a simple application. Obviously, I've left out all of the error handling. Let's look at it for the side of the instance store. So what happens when I actually want to implement one of these beasts under the covers? And I'll do that again by just jumping in and looking at what I am going to implement as an author of an instance store. So you see instance store is an abstract class. SQL Workflow instance store is just a subclass that fills these in. I have some handle management. And you'll notice that all these public methods, which are all the entry points, are not overridable. And that's because that's where the durable instancing framework is plugging in, intercepting all the calls, and then translating that back into what I'll actually be doing. So when I'm writing an instance store, instead of implementing the handles myself, the handles are actually how durable instancing is tracking the state of the system. I'll just get callbacks saying, a new person has shown up, asked for a handle, person's gone away, handle's freed up, and I'll be able to attach state to that handle so that I can recognize the person as they come and go. We'll also translate the execute, which is running these commands. So you'll see that the execute here is the one I called and got back that instance view. You notice that, again, durable instancing is going to intercept that before my instance store sees it. Instead, I'll see this try command. And instead of the instance view, I'll get a different class coming in, the instance persistence context. This is where I actually see the transactionally dirty data. So if I look at the instance persistence context, what it'll look like is actually like a database log. We've turned the instance store basically into a state machine. We've identified a series of permissible state transitions, things like loading an instance, associating an instance key, changing one of those metadata values, and so on. And as your instance store implementation is doing physical changes to your database, you report back saying, I did one of these operations. So when I executed that load workflow by instance ID command, I'll have loaded an instance. When that's done, I'll tell the persistence context that I've done the load. If this was an activating one where I now associated that new correlation key with the instance, I'll tell it that I did the association. If I read or wrote some metadata, I'll tell it that I did those operations. And durable instancing actually cooks down this transaction log once the transaction commits in order to give me that transactionally consistent view to the application host. So from the host side, I saw a perfectly clean world of data. From the instance store side, I saw a series of events going on, but neither side had to actually care about resolving that transaction and resolving those consistency issues whenever a transaction rolls back or whenever I have dirty data in the system. That was all taken care of for me. So now that you've kind of seen some of the behind the scenes of an instance store, let me jump back to that simple persistence participant demo that I gave you earlier. Since we've got so many Win32-like concepts, I call this the persistence EX demo. So if you're a real .NET person, you'd call it persistence 2. What I'm going to do here is show you that there's more to that persistence pipeline than just the ability to map data, as you saw, in order to promote values out of my instance data. So there's actually a series of steps going through. It's similar in terms of the behavior system that you're possibly familiar with WCF. We got a big piece of feedback on that behavior system actually in terms of design, which is you really hate it that whenever I have 10 people that want to participate in something, that I actually have to care about order of operations and the order that things are called in because they're stomping over each other's data in a visible way. So we turn this into a pipeline where I can avoid having to worry about the order of execution. So imagine that on my application host, everyone has walked up and said, here's my persistence participant. We all want to be involved in this process of transforming how my data looks. At the first stage of the pipeline, we'll collect all the data in the system that's known. The host will give us the variables. We'll run each of the persistence participants telling you, hey, do you have any data for me? If so, give it to me. But we won't show you anybody else's data. So it doesn't matter in which order that we do this collection process. Then we'll go back for a second phase. In that second phase, we'll show you what we had collected in the first round. We don't let you modify or remove any of those values, but we'll let you contribute new values. And that's that map that I showed you, where I could add new values in, having seen the variables that were given to me by the host. We'll bring that to the store, and we'll have on the reverse side a similar publishing process. We'll run through the persistence participants, saying, here's all the values that we got back from the store. Would you like to contribute any additional data? So let's look at an example of that where I'm going to use a persistence participant to contribute data that wasn't already in as part of my instances. So in this sample here, I want to do a quick persistence participant. You'll notice it's the same class that I'm extending off of. And here I want to maintain an ongoing count. So I'll have the ability for people to increment my count through my host extension. So anybody can call and say, increment this number. And whenever I persist, I want to remember the value that you had last told me. So this is building additional state into the application host that exists independently of my variables in my workflow program. This allows me to do extensions, such as when I've got a delay activity and I need to have an extension in order to actually implement that. This is the mechanism that I can use in order to contribute the additional information. So what I'll do is participate again in some of those pipeline stages, and I can choose which of the stages I'm going to jump into. Here I'll jump into collect and into publish. You'll notice again, in order to customize the data that's going in and out of the system, it's something on the order of about 5 lines of code. So whenever my collect is called, what I'll do is give you back that dictionary. Here I'm going to take a name, which is, again, just a name that I define so that I can recognize my data. And I'm going to give you the value for that. And now the instance store will have information about my counter. It'll remember it as part of persisting the instance. And when it comes back, I can pull it out of that collection and promote it back into my activity extension. And so in this way that I can leverage the persistence system to load and store additional data that I need as part of my application host in order to maintain state. Now I want to change gears a bit and talk about the monitoring stack that you saw side by side with persistence. Monitoring, fortunately, is going to have a much simpler model, and that's for the reason that monitoring is recording exactly what happened as it happened in a historical sense. If I change the variable 258, regardless of the fact whether the transaction rolled back or the persistence failed, I still change the variable 258. We're not going to try to coordinate the tracking information that's coming out with the rest of the system. So I have a much simpler picture in terms of the mental model that I have, as well as going through and running through the system. You saw a very similar presentation earlier today if you went to Mark Fussel's talk when you looked at how tracking works here. Again, there's going to be a distinction between what's in beta 2 versus what's in the final release, so I'm going to go over that very briefly. As part of my workflow runtime, I've got my scheduler running. It's going and executing my activities. It is raising events as part of that activity execution process. And those events are going to be translated into a schematized set of records, which is saying here's a classification for different types of events that can happen in the system. Those records I can then take as just a big fire hose and say, here's everything that's happening in the system. Or I can selectively query a portion of that data so that I can receive a smaller stream, only the events that I'm interested in. So what I do is add a tracking participant, very similar to a persistence participant, to the application host that registers me as with the tracking provider, saying here is someone that is interested in receiving notifications about how the system is being changed. And I have the ability to define a tracking profile. That's basically a filtered query, which says, given all events in the system, I only want to see a portion of those. Once I've got my tracking participant, which is getting the data that I selected, I can pump that data out to anywhere that I want. So I can, as part of the out-of-the-box experience, use the ETW tracking participant, which is going to use the ETW analytic channel in order to put the data out. What we have as part of AppFabric is also the ability to sit on top of ETW. There's the event collector service, which is receiving all the ETW events and can take those events, put them into some database storage. We also have a sample for directly using a SQL tracking participant. So I go directly from the participant into writing the data into SQL. And again, because it's schematized data, I can build on top of that. So I can write tools that look at the history of the execution of my instances, visualize that, make decisions, control how the system is run. So let's look at an example of writing one of these tracking participants. And I'll first go from the side of just selecting a portion of data that I'm going to be interested in. So here's my tracking participant. I'm going to just new up one of the existing ETW tracking participant here. And then I have the ability to put this profile on, which lets me specify queries that I'm interested in subscribing to. So I'm going to continue my online business example. Let's say I've written my own item delivery activity. And I want to, as a debugging step, know every time that my activity gets canceled. So what I'll do is add a cancel requested query. I'll set the activity name to be star, which is any activity can be doing the cancellation. I'll set my child activity name to be my delivery activity. That's the activity that's being canceled. And then I'll just add an annotation here saying that I want this as information level. I can actually add more queries here. And if you're at the Visual Studio 2010 tips and tricks. As one of the new changes is my ability to search within words. So if I just type query here, it'll tell me all the different classes that contain the word query. And this is basically the list of all the query types that you can select from. So I'll pick the activity state query. Again, I'll specify my activity name. In this case, it's the delivery activity. I can say what states I'm interested in it firing on. I'll say it's the started state that I want to listen to. And then I can actually specify my variables that I'm interested in. So let's say I'm going to put that account name. Oops. And now every time that my activity starts, I'm going to track the fact that it started as well as that variable, so that I can now correlate back together both all the times that my activity started as well as all the times that it was canceled. So that's the quick look at the query side. But now let's look at what it takes in order to write one of these tracking participants. You saw that it was a pretty big task in order to write one of those instance stores. But it turns out it's much, much simpler to write a tracking participant and actually do the storage yourself. And to prove that to you, I'll actually show you how this ETW tracking participant is implemented using my favorite tool, Reflector. So I've got Reflector pointed at the actual beta 2 bits here. So you notice that it's version 4 here. I'll pull up the ETW tracking participant. Notice that it's implementing the tracking participant class that we were talking about. On the tracking participant class, it's a little bit hard to see here, but there's basically one method, which is the method track. There's also an async version of it. So let's look at how ETW has done it. If you notice that it's getting in one of these tracking records, which is that schematized information about how my system has just performed an event. And it's looking at the different types of tracking records just to see which ones it has in the system. And it'll call off a different method for each tracking record. I was using the cancel requested one, so let's look at the implementation. Again here, all I'm doing is checking whether I should be tracking this particular record. And if so, let's look at what it's doing. OK, it's basically taking the record in, serializing that out into some interesting payload, which is just formatting into bytes, and then stuffing it over DTW. That's the entire implementation. You could do a tracking participant off to your own storage location in about 25 lines of code. So there really is nothing that we're hiding here in terms of writing the tracking participants and writing the storage. But let me show you a little bit of a different example, which is now I'm not just interested in recording what happened in my program. I want that record to also be consistent with exactly what executed. So if I rolled back, I want to forget the fact that I started that activity or canceled that activity. So if I went through my program 4 times, I don't want to see 4 start notifications. I just want to see 1, which is the one that was successful. And we can actually do that by leveraging tracking together with persistence in order to join the systems together and do the tracking underneath the persistence transaction. So again, let's jump into the code here. And here's a tracking participant that I wrote. And all I'll do is have a list building up, which is the tracking records that I've seen that I haven't committed to persistence yet. And you'll notice there's a new class here, persistence IO participant. This is the cousin of persistence participant. And we'll see how this looks in a second here. But all I'll do is whenever somebody calls my track method, I'll stick the record in the list. And now my persistence participant implementation is what's going to actually do all the work. So let's go and look at that really quickly. So if you notice, persistence IO participant is just an extended version of persistence participant. I can do any of those pipeline stages to map, collect, publish that we saw before. But it also has the ability for me to go off and execute asynchronously. So during the load or save process, I can get called back saying, I'm in the middle of a persistence episode. You have the free reign to go off and start asynchronous work. You can specify whether you're going to have the ambient transaction set for both save and load. And so I can use this as a way to do additional work during persistence. So if I want to customize how persistence works, I don't want to save my data in the same instance store that everyone else is. I'll take a few of my variables, write one of these persistence IO participants, and go off and do my own database work. Or I'll go off and do my own file work, or send it over the network. I can do anything that I want because it's an async callout. So once I've got one of these persistence IO participants, and here I've built one into my tracking participant, the only reason these are not the same physical classes is because we have a lot of abstract-based classes in the system, so you have to structure it as if these are separate objects. We do that because the way that participants are added to the system is just throwing a bunch of participants into the extensions collection of my host. And the extensions collection is going to just be searched through based on the types that I have. So we have to have a separate type for each type of participant. So here I've implemented my save method. So I'm going to get called. And I said as part of this that I want to be called with the transaction.current set to the persistence transaction whenever I save. So now I jump into begin on save. I know that transaction.current is set. If that was an application transaction, so I'd use something like a transaction scope, it would be part of that same transaction that all my application work is being done under. If I didn't have an application transaction, persistence would have actually started a transaction there just for the two of us to work together in. So we'll take care of it just like you have transaction scope required. Whether you float a transaction in or need to create one, we'll make sure that the transaction's there if you tell us you want a transaction. Then I'll take all of my unflushed records, just make a private copy of them so that nobody can change this list while I'm going off and writing them. And I'll call off using my async call, saying I'm going to go and start flushing those records off to wherever I want to store them, giving out the list of records. Again here, because this is using the asynchronous programming model, you're probably going to spend more lines of code writing begin and writing async result than actually doing the work. But hopefully we'll have better ways of doing asynchronous programming in the future that will make this the same 5 lines as you have for the other examples. So let me do one final thing, which is to talk about some of the other talks that we had. Obviously, in 60 minutes, I couldn't cover all of the extensibility points in the system. And I want to call out a couple of ones that are particularly interesting to go and see. If you saw Matt Winkler's talk about extending the activity model, writing your own activities, Matt used tracking participants, persistence participants under the covers. He kind of waved his hands and said, magic happened, and here's a value that showed up. You've just seen how you actually make the magic happen. We had Mark Fussell talk about workflow services and the AppFabric. So you saw a lot of the demos running the tools. So those are the things that are actually built on top of this system. So for example, AppFabric lets me create persistence databases, delete persistence databases, configure persistence on my services, so I never have to touch any of this stuff. It's all done through a UI-driven experience. And Mark showed you those demos showing you that UI. We had Bob Schmidt talk about how workflow, the runtime itself works. So if you wanted to know about all those events that are going back and forth between the runtime and the application host, that's the talk to go and see. We had Ed Pinto show us how WCF is evolving in 4.0, including the use of some of the monitoring features. So you can see kind of the differences between WCF monitoring right now and WF monitoring. Hopefully we can grow those together in the future. And finally, you saw in this talk the extensibility of how to choose an application host, how to write my own application host, how to choose or extend the persistence system as well as the monitoring system. And finally, that storage layer, which you can customize however you want. You might notice as part of AppFabric, it not only covers all these hosting technologies we talked about, but AppFabric also includes the velocity cache, now just called AppFabric, which is convenient so that you get both together. And that's a recommendation that I've got for what you might want to look at in storage solutions in the future. So I'm going to use this opportunity at the end here in order to quickly show you some of the differences between Beta 2 and what you'll see in the final version of 4.0. So what I've got here is actually just the instance store class that you saw before, and we'll diff that with, and we'll diff that against the instance store class as you'll see it. So you'll notice 2 things. One of which is we're actually making the naming consistent so that you no longer have system.runtime.persistence. You'll actually have durable instancing all over. And finally, you'll see this eventing callback system. So here's an additional set of hooks that I need to plug into as an instance store author to say that as an application host, I'll call wait for events, waiting for instances to be ready to run. And they can be ready to run either because a timer is fired, because a machine has crashed, I want to load balance, move instances from machine to machine. It'll just say, here's instances that are ready to run for your particular host type. And I'll get these notifications so that when I see that, I can tell my application host, there's an instance out there. Why don't we go off and load it? And there's a command that actually goes and loads any instance that is ready to run that matches my particular application host. Also in here, let me show you one other change as a result of this. And here I'll actually show you the schema behind the workflow instance store. If you have not seen this before, this is actually installed in your .NET directory. So if you go to c:windows/microsoft.net/framework, if it's a 64-bit machine, it's framework 64. / the version number of .NET. There's all these scripts in here, which is how these instance stores are actually created. We can't ship you databases, so we give you the T-SQL that's going to be run when those databases need to be set up. And these are all the scripts that if you're using AppFabric, you never have to care about. So let's diff these two to see how they're changing as a result of now having to have the instance system in here. So you notice that there's one change into my instance table, and that is that I actually have to know about the type of application host that I have. And that's so that we can match up application host with a particular instance so that we have the right program definition in order to run you. Then you'll see a big chunk of code here, which is maintaining all that list of all the instances that are ready to run. If I'm writing my own instance store, this is something that I'm going to have to implement in order to be able to serve those events up to you. And then finally, you'll notice that there's a big chunk of code disappearing, which is that old workflow management service that you had to have previously on every machine. So we actually simplified it quite a bit by moving from the endpoint-based way of activation in order to get to the eventing-based method. So that's all for my talk today. I do want to encourage you to fill out evaluations. If you loved it, if you hated it, if you wanted more code, less code, just tell me. I believe we are giving to charity for every evaluation filled out. So that's one thing that Microsoft is doing. And then finally, I'll take questions. Because we have the next speaker coming in, I'll probably be down here. Just come up whenever you want to talk. And thank you for coming out today.